Definition. This slide shows general composition of a lubricant. Base oils, 4.2% VM in an additive package, and in the barrel, you see what's in the additive package, a variety of different additive types, dispersants, detergents, antioxidants, so forth. My definition of new engine oil additive technology is new additive components, anything that's in that barrel, additive packages, the formulation of those additive components in the barrel, new VMs, or new 4-point depressants. And I want to really focus on new additives, new VMs, new 4-point depressants, as opposed to new additive packages. So components that are sort of new to the world. All right, drivers. First driver. We've heard this today multiple times, is emissions. This slide shows one example of some of the emissions drivers. It's heavy-duty diesel emissions regulations in Europe. PM on the y-axis, NOx on the x-axis, getting tighter and tighter, and for Euro 6, they'll be extremely tight. Lubricants. So on this slide, on the top, the blue arrow is some of the USA and European emissions legislation. Next line down, the figures are various technologies OEMs have employed to meet those emissions legislations, roughly in the order of the emissions legislations. And then finally, at the bottom, is the impact on the lubricant. This slide shows data in the MAC T11 test. So it's viscosity increase on the y-axis, percent soot on the x-axis. And it shows two results, a CJ4 oil and a CH4 oil. CJ4 oil does much better. Second example, this is driven by compatibility with aftertreatment devices, so low SAPs. The problem with low SAPs is the components in the lubricants that provide SAPs also provide a lot of performance. So when you reduce SAPs, you have to somehow make up that performance. Next slide is an example touched again today multiple times from gasoline side. Three-way catalyst durability. We know that these catalysts are susceptible to poisoning by phosphorus. Successive ILSAC and SIA specifications have led to reduced phosphorus levels. GF5 did not reduce phosphorus level, but it put in a new test requiring phosphorus volatility requirements. And that has driven new ZDDP technology, new ZDP components. Okay, second driver, fuel economy. I believe Eric mentioned this today already. In the USA, the EPA greenhouse gas emission standards are going to require significant increases or improvements in fuel economy. This slide shows projections of those improvements necessary. Second biofuel example is biodiesel, and the UOP speaker scooped me on showing the chemical structure of biodiesel, so I'm very disappointed, but the rapeseed field on the left gives us a precursor to some of the biodiesel molecules, one shown on the right. And the last topic on drivers is that I want to cover is specifications. These drivers, when they go into specifications, that gives us the clear signal and clear direction to develop, and the clear timing to develop new components. Next slide shows a little bit more insight on how specifications might drive new components technology. It's a plot of the number of engine tests required in API diesel categories, starting with category CA. I don't know the date for that. Maybe Kevin can help me on that. Nobody I could talk to remember. Expanding up. Okay, now on to challenges. First challenge. You're going to develop and commercialize a new additive component. You've got to invent it and scale it up. And in our industry, a lot of us probably, and in other industries as well, use a pipeline process. Our R&D group invents many candidates. We test, prioritize, promote the winners, eliminate the losers, and eventually, very few will be subject to process development, scale up, commercialization, and they fall out into that manufacturing tank. Second challenge, complexity. All these drivers, diverging global specs, they can get out of hand very quickly and result in a large number of additive components and additive packages. So our colleagues in operations have to make, store, blend, transport all these additive packages Third challenge, regulatory. Like emissions, fuel economy, global regulatory requirements, and processes governing how we use substances are getting more stringent. REACH has already been raised today. A major focus of REACH deals with existing components that came into use under a less stringent system. It's a necessary step, new chemical notification. And essentially, in general, new substances have to undergo toxicology and other testing before we can use them. Makes sense. People often confuse this with registration. Registration comes later, after you do the new chemical notification, and after you've been using that substance for a number of years, it's added to a country's registry or inventory, and then it's said to be registered. We're all happy because we can use it, but there's a lot of work to be done before it gets to that inventory or registry. So what are the challenges in this new chemical notification? Well, the test requirements are often unclear, negotiable, prone to change in mid-course. The tests are expensive, and maybe the most important thing I see, I've left off the slide, there's a lot of tests. I'm going to show you on the next slide how many. All right, the fourth and last challenge, intellectual property, an oldie but a goodie. The first aspect of intellectual property, freedom to use. Areas of interest in the lubricant additive field are heavily patented. All right, here's a slide. U.S. patents. Issued U.S. patents on dispersants, composition of matter. So one country, USA, one type of patent on dispersants, composition of matter. And this is a result of a Lubrizol search between 1971 and 2009. There's a lot of patents on dispersants. So, if you wanted to introduce your dispersant technology in 2009, you need to search, find, read, absorb, understand, and not infringe upon all those patents from 1989 through 2009. So that is a big undertaking in itself. Okay, summary. Drivers for new technology, we've heard of many times today. Emissions, fuel economy, biofuels are some big ones right now. Key challenges in developing that technology.